Welcome to today's deep learning tutorial. In this video, I'm going to explain one of the most fundamental concepts in the modern AI, or we call as a Gen AI, and that's embedding vectors. Now, if you're thinking this sounds complicated, don't worry. By the end of this video, you will understand exactly what embeddings are, why they are so powerful, and how they are literally everywhere in the AI systems you use every day. This concept is absolutely important if you want to understand how neural networks and deep learning actually work. So let's dive right in. What are embedding vectors? Imagine you're trying to explain to an alien what a dog is. You can't just point to the letters dog and expect them to understand, right? You would need to describe its characteristics, like it has four legs, it barks, it is a loyal companion, etc. Now, that's essentially what embedding vectors do for computers. They take the raw data, whether it's the text, image, audio, and convert this into the numerical representation that captures the essential meaning. Let's look at the flow here. We start with high dimensional complex data set that's often sparse, meaning most values are zero. Then we use the neural network to transform this into dense vectors where every number has got a meaning. And as a result, a compact representation that preserves the semantic relationship in the data that we have got. Now, this is really revolutionary because now computers can understand that the dog and the puppy are related, even though they are completely different words. So now let's look at some of the key properties of embedding. You're seeing I have written here distance is the similarity. What does this mean? In the embedding space, the similar things are placed close together. It's like organizing your music library not alphabetically, but by how similar the songs actually sound. Let's look at the comparison here. So before embeddings, we have got the sparse representation. Now you can think of it as a one-hot encoding, if you have learned that, where we go and represent a word with a vector having all of the entries as zero except one. Now there is no semantic relationship between the data that we have using this sparse representation. It is it is at the high, it has high dimensionality and it's very difficult to understand. But after we convert the data into embeddings, what we get is a dense continuous vectors where every dimension carries meaning. Similar inputs clustered together in space. The neural network can now process this efficiently, and most importantly, semantic relationships are preserved. This is why modern AI, the Gen AI systems are so good at understanding the context and the meaning. Now let's, take a look at the example we have spoken earlier from one hot encoding to embeddings, like, before embedding to after embedding. So if you see here there are, if we have, for example, the 10,000 words such as cat, dog, fish, and more, each out here we are talking about the five words of cat, dog, fish, and a couple of more. And if you see to go and represent the cat, we have one made for one entry, other entries are zero. Similarly for dog, the second entry is one and other are zero, and so on and so forth. Now so if you have, for example, the 10,000 of such words will have the uh, will have the 10,000 dimensional vectors where almost except one, all of the entries will be zero. Now that's incredibly inefficient and tells us nothing about what a cat is if we have 10,000 dimension. Now look at the embedding on the right side. What we have got is from 10,000 we have converted into the 300 dimensional vector where every single number has got the meaning. So these numbers collectively encode what cat represents, its characteristics, its relationship to other concepts, and so on and so forth. Notice how the cat and the dog has the similar embeddings numbers while the fish has a different one. So the embedding has essentially learned the relationships. This transformation from 10,000 dimensions to 300 dimensions while keeping all the important information is what makes the embedding as a magic. Let's take a look at the handwritten digits example. So if we have got a set of handwritten digits, now what we are looking here is the visualization in the two-dimensional space. Now each colored dot represents a different handwritten digit that has been converted into an embedding vector. Notice how all the zeros clustered together in red and all the different ones present in the data set clustered as blue. This is semantic clustering in action. The neural network has learned that all variations of the three share common characteristics, so it places them closer together in embedding space. When you see digits look together like 6 and 9, they're positioned closer to each other than to the very different digits like 1 and 0. Now, this is exactly how computer vision systems recognize handwritten text, the postal codes, and even your handwriting on tablets. Similarly, I have shown you the example of the word. This visualization shows how words are organized in the embedding space based on their meaning. Look at these clusters. We have animals grouped together in the red, the, the technology terms in blue, and the clothing items in green. This beautiful thing here is that the computer learned this relationship just by reading massive amounts of text. Nobody told it that the dog, cat, and the tiger should be grouped together. It discovered these words of appear in similar context. This is why when you type the dog in search, it might show results for the puppy. The embedding space knows these words are semantically related. Now, what are its applications and use cases? So, if you see, first of all, in the case of visualization and analysis, we can compress complex data into 2D and 3 dimensional data set for human understanding while preserving the important patterns. In case of neural networks, embeddings are fundamentals. Those final layers in CNNs that I mentioned, they are creating embedding vectors that capture what the network has learned about the images. For natural language processing, every major language model from word to vec to the transformers powering the ChatGPT relies heavily on embeddings. And for the recommendation system, what Netflix suggests a movie you might like, it's comparing embedding vectors of movie uses and viewing patterns. The real world impact is massive. Search engines use embeddings to understand your queries. Social media platforms use them to curate your feed. Autonomous vehicles use them to recognize objects, and medical systems use them to analyze scans and the diagnosis. So, finally, let's wrap this up with the key takeaways. Embeddings are the foundation of modern AI, or the Gen AI, because they solve a fundamental problem. How do we represent the real world data in a way that computers can understand and process efficiently? So the core concepts are embeddings transform the high dimensional data into the low dimensional representations. The similar items clustered together in the embedding space. The dense vectors are more efficient than the sparse one-hot encodings, and finally, the semantic relationships are preserved. And the benefits? Well, we get the dimensionality reduction without losing important information, the semantic understanding that enables better AI performance, the computational efficiency for large-scale applications, and the ability to transfer learning across different domains. So here is the bottom line. Embeddings enables AI to understand meaning, not just recognize the patterns. They are the bridge between raw data and the intelligent understanding. So journey from raw data to semantic vector to intelligent AI. That's the power of embeddings. So well, that's the embedding vectors explained. If this helped you understand this crucial concept, please give this video a like and subscribe for more deep learning tutorials. In the comments, let me know what other deep learning concepts would you like me to break down, maybe attention mechanism, transformers, etc. Remember, understanding embedding is your first step towards truly understanding how modern AI or the Gen AI works. All right, so thank you for watching, and I'll see you in the next video.